Hey guys, welcome back. So this is part 2 on this Winco Dyna generator. This was something I picked up dirt cheap on Facebook. Actually got it from a 15-year-old kid who worked at a power equipment shop, and this was one of their rejects. So I thought it would be a fun project to see if I could get it going, and that's what the first video mostly focused on. And luckily we got it going. It started first or second pull after cleaning the carb, and it made power. So I thought we were in pretty good shape, but I quickly realized there was a problem. Now, this generator head is rated at 4,000 watts and the engine at 8 horsepower, and the most load it could support is about a 1,500 watt load, which only requires about 2 or 3 horsepower. So there was about 5 horsepower missing from this engine. And I didn't have a leak down tester, but I did pressurize the cylinder and found that the intake had a pretty significant leak. So I lapped that valve, put it back together, did another test, and it was about the same. I didn't notice too much of a difference. So at that point, I kind of ended the video because I really couldn't figure out what was going on with the top end. But today, I think I figured it out. So let me get you set up in a stand and show you what I found. Okay, so another way to do a leak down test without a leak down tester is to rotate the engine to the compression stroke, which is where I'm at right now. So from here, where that magnet is, to about here is the compression stroke. And when you rotate the engine during the compression stroke, you should be able to let go of the flywheel, and the pressure in the cylinder should actually spring the wheel backwards a little bit. And while doing that, I realized there's absolutely no spring back, which tells me that there must be a pretty big leak. And I was doing this a few times and noticed a hissing sound right there. And that got me wondering, is that the compression release or is that something else? So I put my ear up to the intake, the exhaust, heard nothing, and finally realized it's coming from the breather hose. So long story short, I put it to top dead center on the compression stroke, pressurized the cylinder again, and let me show you what I found. So in order to do this, I'm just using my compression tester, the hose, and I'm filling the cylinder with compression, basically. I have the flywheel locked with a pair of channel locks in place while I do this. So that is a pretty significant leak. I did order a proper leak down tester. So before tearing this thing apart, I'm going to do a proper test and see where we're at, kind of get a baseline, and then we'll tear this thing apart, fix the problem, and we'll test it again. All right, the leak down tester's here. I'm just going to adjust this to zero out this gauge. And that's pretty good. So a healthy engine should be about 10% or less, which is right here. Anything more, and you should be pretty suspicious of the health of the engine. So I've got the flywheel rotated on the compression stroke to top dead center, and this hose in the spark plug hole. I'm just going to pressurize it and see what the leak down is. That's pretty bad. That's like 50%. And it's coming out the exhaust and the crankcase. And the intake's actually pretty good. That's the only valve I lapped. I probably should have lapped both. Anyway, this thing has to be torn apart. So I'm gonna cut the video here, just get the carburetor, muffler, fuel tank off, and I'll turn you back on for the good stuff. All right, so I got all the peripheral stuff off on this side, as well as the fuel tank on that side. And I think I'm at the point now where I'm ready to pull the power head. And this setup's a little different than what I'm used to. Usually there's an end housing, a bell housing, and 4 bolts running on the outside here, kind of sandwiching everything together. And although this doesn't have that exact style, it does have 4 bolts, and they run the length and do sandwich everything together. This end plate does come off once you remove those bolts, and there is a plate down here too, which is connected to the engine. So by removing these 4 bolts, theoretically this can slide out. I just need to remove kind of the mounting points on either side down here to free up the stator housing. Now, normally before you do that, you have to remove the brushes. And believe it or not, I did find a parts diagram for this generator head. And from what I can tell, there are no brushes. I believe this is a brushless setup, which is good. So I don't need to worry about that. Theoretically, I could just slide the stator out, outlets and all, but there is a ball bearing here in this end plate, and that's what holds the rotor kind of in place. And depending upon how tightly that's pressed in, I may not be able to slide this out. In that case, I'll have to probably disconnect the wiring, get this plate completely out of the way, and use a puller. Hopefully I don't have to, but I guess we'll find out in a minute. All right, so we're in. The secret was just whacking it with a screwdriver to get this end plate off. And that's what was holding onto the bearing. Anyway, we're in, and you can see there are no slip rings, so this is brushless. And this is the giant capacitor I was talking about. So I would like to think it's discharged, but yeah, I'll try to stay away from it. This is probably the best rotor I have ever seen in a generator. All the ones I've worked on, the rotor is not protected with a coating, and there's slip rings. And most of the rotors fail because a wire falls off the slip ring or a wire breaks due to the forces involved of this thing spinning at 3,600 RPM. But with the way this is built, I don't see it failing. Not for those reasons, which is usually the point of failure. So this is very well built. The next issue I think I'm gonna have is just getting this bolt out and of course getting the rotor off. Now, typically I fill the cylinder with rope so that I can torque down on this without the engine turning over. In this case, the spark plug's actually over the valves, not the piston, so I can't fill it with rope. Ideally, I'd have a strap wrench for the flywheel, which I don't have, but I'm gonna have to come up with something in order to get that bolt out. And in case you're wondering, the jack wasn't supporting the weight of the engine and stator very well, so I did have to improvise and just give it a little more holding power so it doesn't flop over onto the floor. So the best thing I can come up with is a strap, wrapped around the flywheel a few times and then tied off here to kind of lock things up. But before I can do that, I do need to get the magneto out of the way. I think those are threads. So I thought I had threads in there, but I've tried everything. Nothing fits. So I'm gonna tap it over whatever's there, and hopefully it'll give me enough leverage to pop that thing out. So unfortunately, the rod I have is too wide diameter. I can't get it down the shaft. And the next closest size I have would be the same size as this bolt. And if I were to push, cut a rod to size, push it in, and then torque down on it, I will damage the threads on the crankshaft. So I'm gonna have to take this engine off, stand it up, and try the hydraulic method to get this off. So in order to do this, you need to put Teflon on the bolts that you're gonna put in there. And you're gonna need, I would say, at least 8 turns of it, maybe more. So I actually added some more Teflon. I mean, there's gotta be at least 20 turns on here. I would say the more the better, as long as it still fits in the threads. Now, I'm gonna use water to get this out. You can use oil or really any fluid. I prefer water just because the cleanup is easy. And in this case, I'm just gonna use a turkey baster to fill it up and then torque down on that screw. And I do still have this sketchy strap kind of hooked up to the flywheel and hooked onto the engine mount area. So hopefully that'll be good enough. You want to make sure you get all the air out, or this may not work. Okay, so in this case, I haven't had much luck with the water. I don't see it leaking up here, but I'm guessing it might be squirting through down at the bottom of the tapered shaft. So I'm going to try oil, which theoretically will squirt out a little slower down there and maybe give me a fighting chance. There we go. So that may not have been the most graceful rotor removal I've ever done, kind of dropping the engine down on the floor, but this engine already has issues, and I didn't cause any more damage, thankfully. Ultimately, I think it was leaking down here, and water and oil really didn't make a difference what I used. I was just turning the wrench too slow. So I ended up going with the impact nice and fast, and that popped it right off. So now for the easy part, we get to fix the engine. Okay, sorry you missed it. I got the flywheel loose. I did try to use a puller, which didn't work because none of those bolts are the right size. I ended up using a giant puller and just applied a little bit of pressure and then gave it a whack right on the end, and it popped off. Yeah, looks like I broke the key in the process. Not a big deal. Okay, well now we know where the aluminum was coming from. Okay, so I was expecting the rings actually, and these rings are in pretty good shape. The piston though is another story. This is quite a bit of scoring and definitely the source of the glitter that was in the oil. Now the other side doesn't look too bad. And the cylinder itself, it's kind of hard to show you. It is dark, but you can see there on the valve side. Now that I can feel just a little bit, especially right there, but it doesn't feel too different from the rest of it, which is in pretty good shape. So we're gonna need to hone the cylinder for sure, new piston and rings, a few miscellaneous gaskets, and the exhaust valve. So we got a ways to go yet. Okay, I got a very important side note here. I was double checking the timing. You know, I reviewed the video from when I initially opened this engine, and my concern was with this ball bearing here, I couldn't see the timing mark on this gear. And from what I can tell, the timing was off. Someone's been in here before and they did it wrong. There's a mark here on the cam right there in between two teeth. And from what I can tell, the way they put it together was that they lined up these marks, which intuitively makes sense, right? And then they put it together. Now, that's not right. The mark here on the counterweight is actually offset by a tooth. You know, I saw some pictures of it online where they had this ball bearing removed, and it's very obvious it's a tooth different. So by doing it wrong by a tooth, you're affecting when the valves open and close and also when the spark happens. So although this top end has issues, this was definitely robbing power as well, you know, if the spark and the valves were slightly off. Now, the proper way to do this is to line it up so that this dot on the cam, which is in between two teeth, lines up with the dot here on the counterweight, so that the dot on the counterweight goes through those two teeth where the dot is on the cam. So it is probably a pretty common mistake, but you know, in this case, I did double check it. I put it back in the way that it was, and then I put it back in the way that it should be. And I double checked the valves when the engine was switching between the exhaust and the intake. And at that point, one valve is closing and one is opening. And that should happen at top dead center when that switch occurs. And when I timed it incorrectly, that was slightly off. So pretty important thing to note if you're taking one of these apart, make sure you understand how the dot works on the counterweight. Just going to pull the exhaust valve out and start lapping it. So the seat doesn't look all that great. You know, this side has a nice shine to it. And over here, it's pretty carbony. So I think that's where the exhaust has been leaking through. The valve itself doesn't look that bad. So spend a little bit of time, lap that in, and reinstall it. I think it cleaned up pretty well. There's a nice, well-defined line going around the valve and similar around the seat. You see that nice, clean, shiny metal going all the way around. So hopefully that'll hold pressure without leaking. But only one way to know, and that's to get it all back together. So let me get this valve back in, and then we'll shift focus over to the piston and cylinder. On second thought, I'm gonna leave the spring out. I'm sure I closed up the clearance when I lapped it, and most likely that stem is gonna have to be ground to get the right clearance. So I'm just gonna move on and get this cylinder honed. And again, despite the way it looks, it actually doesn't feel any different from the other areas adjacent to it. So I think a honing should straighten this out. So this went on for some time. Gonna spare you guys, but just to give you an idea, I would do this for about a minute, you know, clean up the cylinder, take a look at how things were going, and then just reapply some lubricant and go for another minute. Basically just kept doing that, I'd say at least 10 times, probably more, you know, until things started looking nice and clean in there. Okay, I don't want to overdo it. You can see kind of here from the pattern on the side. Things cleaned up pretty well. We got a good pattern going on, and all the vertical lines that were on this side are gone. So I think we're in good shape to move on. Got everything all cleaned up, just washed out the cover and the block with soap and water, and of course let it dry. So that's all set, pretty much ready to go. Now, initially I was being cheap about it. You know, I bought a used piston, and it's obviously used. You can see some scoring on it, nothing significant, but not new. And the one I pulled out obviously is a lot worse. So I was trying to justify it, you know, but then I got to thinking, just honed that cylinder. And when you do that, you're supposed to put new rings on. You know, this is kind of a budget build, so I again, was being cheap about it, but it was bugging me. So I went looking at a new rings, new set. It was like $25, which I was gonna do until I found this. This is new old stock, piston and rings, only $45. So I couldn't turn that one down. So this thing is pristine, and of course the rings to go with it. So I'm gonna get the rings on that piston, move the connecting rod over, and then just start putting this thing back together. One thing you don't want to overlook is the ring gap. So this is the compression ring, and I tested the gap. It's at 10 thousandths, and I tested it at the top, middle, bottom. Consistent 10 thousandths all the way. And did the same for all the rings just to make sure, and we're good. Now, I don't know what the spec should be. The tighter the better as far as compression goes, but if you get too tight, you're gonna cause severe damage to your engine. So yeah, just keep that in mind. I did check too the gap on the original ring, and it's at 3 thousandths, which I think is a bit on the low side. Might be passable, but yeah, I'm not sure I'd want to take that risk. Skipped ahead a bit. I already got the oil rings on. Those are pretty straightforward. The metal's fairly flexible, so I don't think there's much danger in it breaking. Now next, we got this middle ring. And this one, you do have to put it on a certain way. It says the groove down, which, this is the wrong ring. Okay, yeah, and you can see it there, the groove. Maybe you can see it. Okay, and lastly, the top ring. This one kind of threw me for a loop. It says it should be denoted with a dot, and it has like a taper right there. And there is no dot, and there is no taper. So I don't think the direction matters. With that said, the old ring did have a dot, as well as the taper. So a little confused why they sent this instruction with this ring, but it seems to be that it doesn't matter because there is no mark on here. Okay, that wasn't too bad. Okay. I did buy a new gasket here for the cover, but I'm going to put a thin layer of our TV going around. I hope I didn't forget any parts. Because it'll be a pain to open this again. Before lapping the exhaust valve, I was at somewhere between 9 and 10 thousandths. Now I am between 6 and 7, so I'm on the low side. I'm just going to take a little bit off that valve stem and try to get it around to 8. right, so that's the 8. I feel just a teeny bit of drag. I think I overshot it a bit. 9's kind of the high side of the spec, which I'd rather have. And that doesn't move at all. So yeah, somewhere between 8 and 9. So that's good. Decided to lay the engine down on its side. I think this will make it a lot easier. At least that's my hope. And yes, I did double check the timing. You can see the valves are right at the transition point here, and the pistons at the top. That's where it should be. Even if you have no timing marks, you don't know what it should be, set it so that you get this, and then you know you're good. Anyway, I went back and reviewed the footage from the first time I had this head off, and from what I could tell, this same point in the valves, the piston was right about there. So a tooth off, not a big deal, right? The engine still ran, but obviously it's gonna cause issues with performance, and that's what we were seeing. So I know the top end was a mess, timing was a little bit off, and I am cautiously optimistic. So we'll finish this thing up and give it a try. So the rotor I did torque down to, I'd say roughly 17 foot-pounds. And these bolts here, they're only at about 50 inch-pounds when I took it apart. I'm gonna tighten it back up to 60 inch-pounds. So I'm just rotating the engine now to see if I hear any scraping down here. And I don't. The only noise I hear are these balls and maybe a bit of a valve noise. So we're in pretty good shape to finish this thing up. Really, it's just the recoil, magneto, of course the carburetor, muffler, spark plug, gas tank. Then we're ready. All right, I think I got all the important pieces. The only thing left is the airbox, which I'm gonna omit at this time. So it's all back together, and kind of looking forward to starting it, but then again not, because if this thing doesn't work, I just spent a whole lot of time on nothing. Here goes nothing. I got the heaters on standby. The fire extinguisher as well shows my confidence level. Assuming it does start, it will hopefully run slow. I did dial the governor spring back, so I'll adjust that back up to 60 hertz and fiddle with the jets a bit, and then try the 3000 watt load. Well, it runs. I'm not sure what's going on with the carburetor. Maybe the governor spring is too loose. Let me try tightening that a bit. Well, the good news is I just put 3,000 watts on it and it held. So that's very promising. Now, I'm not quite sure what's going on with the governor. It's overly sensitive, I think. I'm not quite sure. So maybe a carb issue, maybe something with the governor springs. I'm just gonna take a closer look, see if I can't figure that out. Got the clone carb back on. Let's give that a try. Okay, great. It runs well for the most part. It handles the 3,000 watt load, staying at about 59 hertz, which is perfect. So this is now a healthy engine. Really the only gremlin I have to chase is that hunting, which only seems to happen at no load. And this clone carb actually is handling it a lot better than the old OEM carb. So I'll probably stick with this carb. You know, I'm thinking two possibilities right now. Either the governor needs to be reset because, well, I had the engine open, so that is a good possibility. Or there was a spring on the governor rod, and I took that off because it was not meant for this engine. In fact, it doesn't show it that it needs a spring at all, and the carburetor is not even set up to hold it properly. But given what I'm seeing, I think I'm going to try that spring before messing with the governor. This is the spring here that I pulled off. Guess I should have left it. Okay, spring's installed. So that's all it was, that little spring, and now it's perfect. Anyway, I was a little nervous about it because I did do another compression test and leak down test before starting it. And although I didn't record it, the numbers were not promising. They were pretty much the same as before the rebuild. It was 60 PSI on the compression test, and it was about 50% leak down. So yeah, my hopes were a little bit dashed after that. But as you can see, it is a good running machine now. All the horsepower is there, and you know, if I had to attribute it to something, I'd say it was the timing. It was one tooth off, and you know, I guess if it's one tooth off, it'll sound pretty good, but it just won't have the power that it's supposed to. Anyway, I think that's a wrap. Hope this video helps someone. Thanks for watching.